So in this video, we're going to be talking about the distance formula. Where does it come from, and how do we use it to find the distance between 2 points? So let's get started. So if you don't have the coordinate grid and we're trying to find the measure of a slanted side, so in this case, the measure of C, we can make a right triangle below it, and A would be the vertical distance, and B would be the horizontal distance in this picture. And in order to find the measure, we could use the Pythagorean theorem, which says if you have a right triangle with sides that measure A, B, and C, then A squared plus B squared has to equal C squared. So if we're trying to find just C, the value of C, we could take the square root of both sides, and we would have that C equals the square root of A squared plus B squared. All right, now let's talk about the same situation in the coordinate grid. If we have the situation in the coordinate grid, we would use the distance formula, which is basically the Pythagorean theorem in the coordinate grid. If you see here, when I'm trying to find this measure here, x2 minus x1, that is basically your horizontal distance, which could be A or B. And then y2 minus y1 is your vertical distance, which again could be A or B. And basically when you're in the coordinate grid, in order to find a horizontal or a vertical distance, you basically just subtract those coordinates. If you see here on the triangle, x2 minus x1 gives you your horizontal distance, and then y2 minus y1 gives you your vertical distance. And so this is just, again, the Pythagorean theorem in using the coordinate grid. So how can you just take the points and basically plug it in? All right, now let's go ahead and use it. All right, so this right here is my distance formula. So make sure you have this written down because we are going to be referring to this formula a lot. So the distance formula is, if I'm trying to find the distance of something, I have the 2 points that I'm trying to find the distance between, you just take the square root of x2 minus x1, you square it, plus y2 minus y1, you square it. All right, so let's go ahead and use the distance formula. So one way you could use the distance formula is if they just are given, if you're just given 2 points and you have to go ahead and find the distance. In this case, we're just going to plug in our coordinates into our formula. So if I'm trying to find the distance, I would go ahead and take the square root of, let's go ahead and label our points. So this is x1, and this is x2, and this is y1, and this is y2. It really doesn't matter that which one you choose to be x1 or x2 or y1 or y2, you're still going to get the same answer. So let's go ahead and plug this in. So you're going to get 9 minus 10 squared for your x's plus negative 4 minus 1 squared. Okay, so and here I'm going to have 9 minus 10, which is going to be negative 1 squared. Again, still keep those parentheses because I'm going to square the entire negative 1. And then in here I have negative 4 minus 1, which is negative 5. I always like to kind of check is my math correct when I'm at this point. So remember what we're doing. This negative 1 is supposed to be what the distance is between your x's. So between 10 and 9, yes, there's 1 unit away. If you're thinking between 9 and 10, then yes, it's going to be negative because I'm going backwards. And then here, your distance between your y's, so your coordinates for your y's are 1 and negative 4. So yes, they're 5 units away. Now we're going to go ahead and square it. Now, when you're squaring, just be careful. Remember that if you square a negative times a negative, So if you multiply a negative times a negative, you're going to get a positive. If you multiply a positive times a positive, you're going to get a positive. So when we're squaring, we're always going to get a positive number out of this. So here I'm going to have -1 times -1, which is just the number 1. And then here I have -5 times -5, which is positive 25. All right, and then we're going to go ahead and simplify this. So 1 plus 25 is going to be 26. All right, so now we want to check, is there a way to go ahead and simplify this number? Is there a perfect square that goes into it? So clearly 25 doesn't go into it. 16 doesn't go into it. Neither does 9. So neither does 4. So there's really just nothing I can do with the square root of 26. That's it. That would be the answer. Now, if it were like a number like the square root of 20, with square root of 12, and so forth, you would go ahead and simplify that. All right, now let's go ahead and talk about how do I use the distance formula when I am given a graph. So one way you can use it is just by getting the coordinates of the endpoints of the segment that you're trying to find the distance of, and then just plugging that into our formula. So in this case, the top coordinate up here is going to be 1, 5. And then the bottom coordinate is going to be 2, -2. So you can go ahead and label your x's and your y's. So I have here x1, y1, and x2, y2. Go ahead and put it into your formula. So again, order doesn't really matter with the x's as long because you're going to square it anyways. The only difference you're going to get is the sign, and then again, you're going to square it anyways. But let's go ahead and just follow our formula directly. So you have 2 minus 1 squared plus -2 minus 5. And again, we're squaring that. So 2 minus 1, that's 1 squared. -2 minus 5 is -7 squared. So in this case, remember, I always like to pause and really kind of look at what I'm doing. All right, so I'm saying that the distance between my axes is 1. So is your horizontal, if I made that little triangle under it, is your horizontal distance 1? Absolutely. And then I'm saying that the distance between my y's, or my vertical distance, would be 7. So we have 1, 2, 3, 4, 5, 6, 7. So that does work out pretty well. So again, it's really just the Pythagorean theorem, and you could always just go ahead and draw that triangle underneath and use the Pythagorean theorem. And so now I have the distance is going to be 1 plus 7 squared is 49. And so I'm going to get here the square root of 50. All right. A perfect square does go into 50, right? Because it's a multiple of 25. So I can rewrite this as the square root of 25 times the square root of 2. The square root of 25 is the number 5 because it's a perfect square. So it's 5 square root 2. And that would be my answer for that. Okay, so now let's go ahead and do another case. So now, sometimes I have to find the length of the segment, and I'm not given a coordinate plane. So yes, this is still a distance formula sort of thing, but it's actually the Pythagorean theorem. So it's actually, can you use the Pythagorean theorem? Can you use the distance formula appropriately? So in this case, your horizontal distance here is 12, so I'm just going to label that A. And your vertical distance is 7, so I'm going to label that B. So if you use the Pythagorean theorem, it would say that 12 squared plus 7 squared equals C squared. So 12 squared is going to be 144. 7 squared is 49. And then we have the C squared here. Now, 144 plus 49, you would go ahead and calculate that. And we would have, if you just do that on the side, don't feel afraid to go ahead and do that. So 4 plus 9, 13. And then 4 plus 4 is going to be 8, plus 1 is 9. Bring down the 1. So we have 193. And go ahead and take the square root of 193. Okay, and there you go. Alright, so this video is done. Just make sure that you have really good notes that you can go ahead and look back in order to use this formula.